You need to learn cloud security or you will fall behind in cyber. Public cloud service revenue reached astonishing 400 billions in 2020 and it's expected to hit 500 billions in 23. That's insane amount of growth just in 1 year. This enormous rise in cloud adoption is both thrilling and concerning at the same time, especially when we dive into the statistics behind cloud security. 3/4 of companies report that 40% or more of their data in cloud is sensitive. That's up from 49% in 21. 82% of breaches involve data stored in the cloud. More than a third of business have experienced a data breach in the cloud environment last year. At the same time, only 45% of cloud data is currently encrypted, while average cost of data breach in 23 was over $4 million. And in today's world, cloud assets are the biggest targets for cyber attacks. My name is Pavel and I work as security consultant specializing in cloud technologies. And in today's video, I want to share with you top 5 cloud security best practices. To kick things off, first of all, you need to understand share a responsibility model. While there are plenty of cloud providers such as AWS, Azure, GCP and many more, the core principle of securing your cloud environment remains consistent across all of them. The shared responsibility model is like a digital deal between you and the cloud provider. It defines who is responsible for what when it comes to security in the cloud. To put it simply, this model says that cloud providers like Amazon Web Services, Microsoft Azure, or Google Cloud Platform are in charge of watching over the security of the cloud itself and the stuff that makes it work, like the servers and networks. On the other hand, regular users, whether they are individuals or companies, have the job of safeguarding their own data and other things they put in the cloud. Unfortunately, sometimes people misunderstand this shared responsibility model, thinking that cloud provider is responsible for everything, even the user data. This can lead to situations where users run things in the cloud that aren't entirely safe. To avoid this problem, it's crucial to understand 3 main service models, which are infrastructure as a service, platform as a service, and software as a service. With infrastructure as a service, cloud provider is responsible for physical security of the building and servers. That means everything from operating system upstream is responsibility of the user. Maybe you have application running on your server. Well, that's your responsibility to secure it as well. With platform as a service, the line of responsibility moves. At this point, cloud provider is also responsible for operating system and software required to run applications. User needs to secure application, access to it, and the data. So for example, maybe you have application that is accessible from public internet. One of your responsibilities would be to protect it from denial of service attack. Lastly, we have software as a service model, where most of the security burden shifts to the cloud provider. Now the cloud provider is responsible for hosted applications as well, and user needs to only protect the data. A good example is Gmail. Google provides you with the application, but you are responsible for managing your email data and access to it. And this doesn't change with any models. Customers always have responsibility for data security, compliance, and access, regardless of the service model they choose. This is crucial to understand because you won't be able to secure cloud environment if you are not sure where the line of responsibility lies. Okay, next one, implement zero trust. It's mind-blowing to me that only 41% of organizations have implemented zero trust controls in their cloud infrastructure. The fundamental principle of zero trust revolves around the concept of assume breach, never trust, and always verify. This means that trust is never assumed, regardless of whether an entity is inside or outside the network. Every user, device, and application must be continuously authenticated and validated before being granted access to resources. In practice, implementing zero trust requires changes to cloud infrastructure, deployment strategy, and implementation. This involves network segmentation and limiting communication between these segments to the bare essential. Any traffic that does not have specific permission is automatically denied access. And speaking of permissions, you need to implement least privilege access strategy, granting user, device, or applications the minimum level of access required to perform their task. This principle minimizes the potential damage an attacker can cause if they gain access. Lastly, zero trust is not something you set up once and you are done. It's a continuous process, which includes monitoring and detection. It's absolutely crucial to analyze your environment for threats in real time. To implement zero trust properly, multiple technologies and solutions are required. I want to mention just few of them. For AWS, you could use AWS Identity and Access Management, Amazon Virtual Private Cloud, and AWS GuardDuty. In Google Cloud Platform, it would be VPC Service Controls, Google Cloud Identity Aware Proxy, and Google Cloud Security Command Center. And lastly, for Azure, it's Network Security Groups, Azure Conditional Access, and perhaps Microsoft Defender for Cloud. Of course, there are many more technologies and solutions to help you implement zero trust, such as firewalls, VPNs, and more. That's why you should always follow official documentation provided by your cloud provider. Alright, further on my list is data encryption. And you might think, well, of course, duh, right? Well, only 45% of cloud data is currently encrypted, so it does deserve this spot. I believe it's mostly because AWS. Not to blame any cloud provider, but not so recently, AWS didn't enable encryption on new objects by default. It was responsibility of the user to enable it, and we know how this goes. Hopefully this number will plummet in 2024, but as of now, it's a huge concern. Data should be encrypted in the cloud itself and when in transit to ensure optimal protection. There are multiple services to help you achieve this in the cloud environment. AWS has Amazon S3 encryption and AWS Key Management Service. Google provides you with Google Cloud Storage Encryption and Google Cloud Key Management Service. In Azure, you can find Azure Disk Encryption and Azure Key Vault. Alright, moving away from data encryption, next on my list is secure your access to the cloud. We have already touched on identity and access management, but I want to further expand on it. Protecting accounts with MFA should be mandatory for all accounts, except maybe for some break glass accounts. Roles should be assigned based on least privilege, which means allowing required users to access only the data and cloud resources they need to perform their work on. Because even with all the checks in place, you need to assume breach at some point, and this way you will limit any potential damage. For example, attacker can steal a token and impersonate victim until the token expires or is revoked, completely avoiding MFA authentication. There are some solutions to protect against such sophisticated attacks. For example, with Azure, you can implement conditional access token protection policy. It's not completely bulletproof, but you want to stack as many protective measures as possible. Alright, the last one you should absolutely keep in mind is security requirements and compliance requirements. Ensuring compliance is fundamental pillar of cloud security, and it carries immense significance across different industries. Depending on the industry, companies hold a lot of sensitive customer information such as card numbers, social security numbers, addresses, and health information. Cloud providers understand the significance of compliance and are instrumental in helping users to navigate this complexity. They offer a range of tools, services, and resources that simplify compliance efforts. AWS Compliance Programs provides comprehensive compliance resources, including white papers, reports, and frequently asked questions to assist users in understanding and achieving compliance. AWS Artifact, on the other hand, offers a centralized repository for compliance related documents, making it easier to access audit reports and certifications. GCP provides something similar with Google Cloud Compliance, where you can find detailed information about compliance certifications. The same applies for Azure. With Azure policies, you can enforce compliance with organizational standards and regulatory requirements through automated policy enforcement and monitor your adherence with Microsoft Defender for Cloud. And there you have it. Top 5 cloud security best practices for cloud environment. Of course, there are many more we could have touched on, such as data backups, security assessments, or DevSecOps. But based on recent breaches, I consider those 5 the most important ones. Thank you for watching, and if you found this information valuable, please subscribe and like. It does help to grow the channel.